Hi, this is your host Alan Bhartia, and welcome to another episode of TFR Let's Talk. We are here at KubeCon in Detroit, and we have with us once again Sean Mara, field CTO at Mirantis, and we have with us UC Nummelin, senior principal engineer at Mirantis. Now let's talk about that the announcement that came out earlier, where folks, updates are always challenging. So talk a bit about what happened.
So what happened is, as you well know, Mirantis is very focused on how do we help our customers deal with this whole Kubernetes journey, the whole enterprise journey of developing applications, running that infrastructure. And our ethos of zero ops is all about really making it as low impact to customers as possible. So when they're running their systems, upgrades and updates and everything just happen. They don't have to think about it, they don't have to worry about it. We've got our new Kubernetes distribution, which is our K0s distribution, which is getting a lot of great traction. And the team behind that were looking at how we do these upgrades and updates. And during that process, they discovered that there is a bug between Kubernetes and IP tables, that when you upgrade IP tables to 188, it will create a breaking scenario for your networking on your node. Now, there are some workarounds, but it actually requires you to be on the node. So right now, the workaround, obviously, the easiest workaround is downgrade IP tables, or don't upgrade IP tables. But that's never a great answer. So team's looking into the details of that. We've got one of the team members here today to talk about this.
As Sean explained, what was the problem, but I want to hear from you looking at the technical aspect. So tell us what actually happened.
We stumbled upon a networking issue in one of our test Kubernetes clusters. And long story short, it ended up being a bug in IP tables, actually, which is, as many of you know, it's the sort of workhorse of Linux networking still, even today. And the bug is actually super bad in a way that it manifests itself in a way that you lose every single bit of networking on a host. So your SSH connections are died and everything.
When you detected the bug, did you also find that people are actually affected by it as well, or it was still at the very early phase?
As Sean mentioned, we do very, very rigorous testing of all of our products as you should be doing. And we were actually, I guess we're not lucky, but we were able to catch this in our actual test cases and test matrix. So basically what we saw was a lot of red flags in the test matrix. And then we were like, okay, something is really, really broken here.
Talk a bit about, once again, when you talk about zero ops, focus on customer, and their workflow should not break, because of that. So talk once again, this is a great example of the work that Mirantis is actually doing. So once again, let's go back to that messaging.
Sure. Yeah. So the whole Mirantis ethos is that our customers focus on what's most valuable to them. If our customers, if the operators, the engineers, the developers are spending their lives dealing with infrastructure problems, they're not building value for their business. So our entire goal is that that infrastructure must just almost disappear from sight. They must be able to deliver applications, get it up and running, get it working, and just not think about it. It should just run. Now, to do that takes an enormous amount of effort on our part. We never deliver anything into production that we haven't thoroughly tested, time and time again. We test every possible scenario. We deliver most of our products supported on many different operating systems over many different infrastructure choices. So I think right now our matrix is nearly 7 operating systems, 5 infrastructure choices, and we test every single one of those with every single combination. And that's really critical for us to offer these guaranteed outcomes to customers so that they can place trust in the systems that we deliver, and that's incredibly important to us. We do that by a combination of course, smart automation that we built into the products, as well as everything around the people that we have, so both our product engineering teams and our support teams. It all stems from those product engineers doing the right thing and the right level of testing, and that connection they have with the community to discover these problems, engage with the community, and get them fixed quickly.
I had a discussion once with Linus Torvalds. It was like, bugs are part of software development. There's nothing you can do to remove bugs. The most important thing is
part of life.
Yes, the most important thing you can do is how quickly you can respond, fix before it becomes a widespread wrong. Once again, talk about how do you folks look at it where you do understand and realize that, hey, there will be bugs, but what we should do is respond as quickly as possible so that folks don't get affected?
Yeah, so it's a two-phase process, ultimately. It's looking for bugs up front before that software goes out to customers. It's thorough testing, scenario testing, having the right pipelines in place. Simple things, CVEs are known. Security bugs are a real challenge for a lot of companies. But if we know about them before we deliver to customers, it's controlling the process of delivering software to customers. We're never just going to a customer, downloading something random off the internet and running it. Everything runs through our pipelines. We deliver packaged binaries to the customers. So that's the first phase. Real world, though, no matter how much testing you do, bugs occur in production. They're just the nature of software, as you pointed out. The second thing is how fast do we react and how quickly can we deliver that reaction. So bug gets discovered, the support team will immediately find a workaround. Sometimes that's change somewhere else in the system to prevent a security challenge. Or sometimes it's the oldest thing, have you rebooted it? Sometimes you just need to restart. But that's not a permanent fix. The permanent fix then runs back into support, back into the product engineering, and due to the way we deliver, we can quickly deliver patches and updates to customers. We do that obviously through our own knowledge, and because we have control of that chain, we can deliver those patches quickly, and then feed those back into the community, and eventually feed whatever the community decides back into the product. But we have the ability to do that really fast, within hours, to the maximum of a few days sometimes.
As we were talking with Sean also, that bugs are part of process. There's nothing you can do but looking at them at a later stage, and also trying to mitigate also. So talk about your process, just to get a bit deeper. How do you folks work? How does your team work that helped in finding this bug?
All right. As everything in software engineering, it's always a team effort. So what we did was we basically put together sort of a war room for the team and started to look at the situation in different angles, and we're super proud that we have a team that's super versatile in different layers of Linux and different layers of networking and Kubernetes and all that. So we were able to attack the problem from many different angles and finally reach the conclusion that it's somewhere super deep in the networking. For us, the key to actually get the bottom of this was the ability to have look at the problem from many different angles. And in our case, we have people in the team who has backgrounds in Linux kernel coding. We have networking skills. We have strong and many years of Kubernetes experience from starting with Kubernetes 0.something releases. So that really allowed us to figure out and coordinate the different angles and get to the bottom of this, I would say, fairly quickly. It took us a couple of days to figure it out. Yeah, but many other teams would have been probably still looking at it.
Does that also make, that is it not necessarily, because once again, as bugs are part of software development, but that we need to look even deeper because CNCF, they themselves have a lot of projects that they do ensure, the integrity of the software. But what does this case kind of, either, hey, this is what we should do now, or no, our process is on place, so we should not worry about.
What this kind of brings up more and more is that although every single project in the CNCF community, they do rigorous testing for their stuff. But in the end, there's many components in your Kubernetes cluster. So you really have to ensure that all of those components play nice together. And essentially, on the lowest level, there's always the Linux kernel that is the workhorse of the cluster. So you have to really pay attention on the testing aspects and verify that everything works together.
What if this bug, escaped your eyes and it actually, people were there who were installing? How scary would that have been?
Super scary. I mean, you'd basically bork every customer's clusters, and that's it. It's like game over for all clusters in the worst case scenario.
I mean, we don't want to talk about predicting things, but how do we ensure that actually that will not happen?
One of the things that this really highlights is also the sort of fragility of the whole ecosystem in a way that updating one small component on your operating system breaks everything else. So how do you ensure that everything actually plays nice together? So you have to either do very rigorous testing yourself. I mean, as an end user, as an cluster operator, or you rely on vendors that provide the testing and tested packages for you.
This time it was lucky that you found the bug in time before, but we have seen in the Linux kernel world also, Equifax was a very good example. The patch was there, but it was never applied. It has happened so many times. And because, once again, as you said, the ecosystem is so vast, there are so many stakeholders, there are so many players. Also, Kubernetes is now being used by companies who are really tech savvy, advanced, and then a lot of folks who are not that savvy. Not everybody goes out and read Mirantis blog or other blogs, and there's so much information, it becomes overwhelming. So once again, how do you look at the problem of actually rolling out those patches? How do you think that, how serious is that problem? And once again, what should be done so that we remove all the middlemen there?
Of course, from our product point of view, we do have auto update functionalities in place, so the clusters update themselves actually by themselves. So it's kind of like going towards this zero ops thinking and approach that the cluster is handling itself, all the updates. But then again, as Sean said, we are a part of a community. So what we are actually as a team now dealing with a lot of the so-called aftermath of the finding that we did. So we're discussing with a lot of other upstream projects and kind of coordinating things with a lot of other projects and following up and this being part of the discussions and proposing different solutions and all that. So hopefully by doing that, we're going to make world a bit better place for all of us.
We've written a great blog, so we're trying to get the message out there. We want to make sure that people understand it. It's not just about, Mirantis and keeping it quiet and fixing it for our customers. That's not the way we work. Of course, we'll fix it for our customers or offer a workaround quickly for our customers. But we want to make sure that nobody else runs into this problem. And I come back to that statement about community. So we've written up the blog, we've tweeted about it, we've put it out on LinkedIn. We're using the channels. We've spoken to a number of people here, really trying to make sure that that message gets out there, that there is a problem, be aware, don't fall into the trap.
Kubernetes being open source, how easy open source makes, for players like Mirantis to actually get into the code, because with proprietary, you cannot, you have to rely on that specific vendor.
Yeah, being open source allows us to really dig into those problems because we have access to that, but it's also about the shared community. I want to specify, it's not about one company, and that's why we're here. We're here about this community at KubeCon. It's about having many eyes on the problem and many people sharing the load of solving all these problems. Ultimately, the whole open source model is we each scratch our own itch, and by scratching the itches together, we eventually solve the problem. So that really is what it's about. Ultimately, it's about community and having many eyes on the problem.
Sean, thank you so much for taking time out and talking about this problem. And I really love the way, Sean, you mentioned, that it's not just a Mirantis specific problem, but, for the whole ecosystem, and the efforts are being done to help the whole ecosystem. So thanks for sharing that. And as usual, I would love to have you folks back on the show. Thank you.